Hello everyone, here's an AI-guided gluten-free recipe transformation, a multi-model ingredient substitution prototype. So for some motivation, traditional recipe conversion is error-prone. Cooks with celiac or gluten intolerance need to trust that no gluten slips through. The system is designed for near-perfect detection. It must parse messy ingredients and never miss the gluten, and adjust for any quantity changes. So for a project timeline, this initially started as an MLP model for binary detection, but the accuracy was limited and couldn't handle the variety. So I moved to a better and a transformer pipeline for stronger text understanding and classification. A share module was added so it could rewrite the recipes directly to their gluten variants. I then built a advanced parsing and normalization that was more advanced than the previous MLP model. It was more JSON based. For fallback, I integrated a gizmo graph that for all those edge cases for those mappings, and I unified everything with a full stack system with a fast API backend, logging, a front-end UI, and complete dataset building. So for system design, I kind of touched on this a lot in the last slide, but initially starts as a pre-processing and the parsing, where it parses the text directly and normalizes multiple things. The normalization is kind of in two steps. The lowercase and stripping white space, and then there's an actual file which maps a bunch of different ingredient names to like a keyword. So for example, if ingredients have two of the same name, but it's actually only one thing, then it goes to a gluten classifier, a substitution engine, which is burp based, and then a fallback of the gizmo model. And then if both of those failed, there is a rule-based fallback, which I touch on the last point, and then a recipe rewriter, which is the share inspired model. The results is I get the full pipeline of the integrating the parsing, classification, gluten detection, substitution, and recipe rewriting. There is an interface and demo that I'll show shortly. Now one of the results is frequency plots. So this is whenever the user is recording, actually using the UI. The backend will actually record the data in JSON format, and then it prints out all these graphs for you, which is hopefully fairly nice. But if you are baking, for example, like this user, and trying to do a bunch of home baking, you'll see a lot of the substitutions is flour and bread base, and this is only after a couple of runs. This data was originally trained off of Kaggle for their recipes originally. Here's a confusion matrix. As I mentioned, it was trained off of the Kaggle dataset for recipes and reviews, and it's greatly improved at learning. It doesn't really miss gluten. There's no false positives. There's very low false negatives where it falsely identifies things, and there's a high precision on non-gluten things where 93% of non-gluten ingredients were correctly left unchanged. Here's the training loss. As the dataset increases, and the training loss will decrease as well, which shows that it has a better model generalization represented learning fairly well. And then overall, here's some performance metrics and model summaries. You guys can go ahead and read that for a second. But here is the UI. So here's the UI directly. You can paste the recipe text or provide a URL, as well as there's optional instructions where you can, if you had the ingredients here, you can paste instructions. It'll be able to parse that with the share module. So here's the URL directly. The URL I'll use at first is these homemade brownies. So you can just go ahead and copy that and provide the URL directly and just press convert to gluten-free. It'll convert all to gluten-free for you, which is fairly nice. It'll actually say a status directly and whether it was substituted. And here's the rewritten instructions that I'll write for you directly. This is all pulled directly from the actual URL. If you ever have any issues with it and want to see something more in depth, there is a raw JSON developer mode, which will show the before and after of all the parsing ingredients, and then the rewritten instructions. And then just so it's, I could test out another recipe. Here is some French toast. This one's a little smaller, since French toast doesn't have as many ingredients, but here it goes into the eggs and everything, and was able to find the gluten-free bread and rewrite that directly. As for the recipe text itself, I have an example pulled up in a file that I'll be able to use. It's kind of mismatched of a bunch of things that do contain gluten, but here's an example, and it was able to correctly substitute. So yeah, thank you guys. Here's my model.